Welcome to LabMinutes.com. In this video, we will look at an EZVPN with the pre-share key and XAuth authentication using a router as a headend. The concept of EZVPN is pretty much the same as the remote access IPSec VPN, where all the configurations will get pushed down from the headend to the client, especially if you run the client mode, but instead of using a software client, it's just going to be your hardware client. Now in our diagram here, this is going to be what we use for most of our VPN video, but for our EZVPN video, this video, we're going to be using R1 as a headend device and R2 as an EZVPN hardware client. And we're going to try to provide connectivity between the two VLAN, VLAN 33 on the left and the VLAN 128 on the right. And we have a test laptop on the 128.32 that we're going to use to test our connectivity. Okay, so let's start our configuration on the router R1. And just to show you the interface configuration, you have the outside interface IP 111.10 and the inside interface 172.16.2.2. Okay. So there's a few configuration that we need to configure to get us set up and ready for the crypto part. And the first thing we're going to do is enable AAA authentication. Login, and this is for the XAuth user authentication. Just going to call it authentication login. Make sure I have a space there. And let's see. Local. Okay, since we're going to have a user password locally, we're going to do authorization, network, call it author local. Since all the IPSec attribute is going to be pushed out from a local configuration. Next, we create our username that we're going to get our remote site to use when it tries to authenticate. Just going to call username site with the password Cisco. Then we need a local pool or a VPN pool IP that will be assigned to the client when it tries to connect. So here we're going to do 172.16.100 starting IP 32, and that ends with 63. Okay. Next, we're going to create a split tunnel access list. Since we're going to do a split tunnel, so we're going to call it EZVPN split tunnel ACL. Permit IP, and on the headend side, that's the VLAN 32 IPs. So we just want the traffic that destined to that subnet to come through and nothing else. Okay. Now that we have all that configured, we're going to start on our crypto configuration. First, we take care of the IPSec phase 1, which is ISOCAMP policy. And I'm going to choose policy number 10. Encryption, we're going to do the strongest encryption that we can do in the router, is AES-256. Authentication type is pre-share key. I'm going to give it group 2, since it's what is supported by the EZVPN client. Hash, SHA, although that's SHA by default. And lifetime also by default is 86400. Next we're going to do the dead peer detection or keep alive. It's always a good idea to turn that on so the peer gets deleted when it's no longer detected. Just leave it at that. So 3 retries and 10 minutes interval. 10 seconds interval. ISACamp, we're going to do XAuth timeout. Here we're going to do 5 seconds. Okay, so now we have the ISACamp policy configured. Next, we're going to configure the group, the VPN group configuration that's going to contain all the parameters. So it will be crypto ISACamp client configuration group, and we have to give it a name. We're going to call EZVPN group. And here, there's a lot of options that you can configure. And each of these parameters is going to get pushed out to the client. First, let's bring up Notepad so we can have that list on the site. So we can try to go through all of them and see what we need to configure. Okay, so we're going to do ACL, that's for the split tunnel that we created earlier, ACL, and we call that EZVPN split tunnel ACL. Let's see, auto update, we don't do that because we deal with hardware client, banner, browser proxy, DSCP, DNS. We're going to give a DNS IP, and that would be our Windows 2008 machine, 32.40, so 192.16.32.40. And domain will be LabMinutes.com. Key, we definitely need a key for our pre-share key group authentication. It's called Cisco. We're going to leave max login, max users by default. PFS, let's say that we want to enable PFS. Pool, and that was the IP pool that we created earlier. Let's see, what do we call that? Okay, so we call that EZVPN pool. We can allow the client to save the password, so there's no need for the user on the other side of the tunnel to keep entering the username password every time they need to connect the VPN. We're not doing split DNS, and we do not have Win server. Okay. So we have a group configuration configured. Next, we're going to do crypto ISACamp profile, and we will call that EZVPN ISACamp profile, just to make it obvious. Is it right here? You need to configure the match identity to complete the section. Let's do that first. So match identity, you have an option of address. It doesn't make sense to do address, assuming the remote site can potentially has dynamic IPs. Here we're going to do group. So when the client's trying to connect to certain groups, it's going to match this particular ISACamp profile, and our group is called EZVPN group. Let's see what other options we have. Same thing. Let's copy that and put that on the site. Got CA, we're not doing certificate. We got the client, so client related config, authentication list. This is the specifying your authentication method for XAuth, and we created one called authn at the beginning. Okay, and then you have client configuration, address. We're going to do response, since the router is the one that's responding to the request coming in from the client. Next we have, let's see, IPSec authorization, and we also created an authorization group at the beginning called author. Okay, got keep alive, and this is a profile specific keep alive which can overwrite the global keep alive that we configured earlier. You can do that by per profile basis, and we have not doing keyring. Let's see, what else do we have? Self identity. We're gonna use address. Okay, that should be pretty much it for IPSec profile. Next, we're gonna create a crypto IPSec, so starting in phase 2 transform set, and we give it ESP, AES, again we're going to do 256, just make the name descriptive, and we also going to do AES, ESP, SHA, HMAC. Okay. Let's see what other options we can do with the IPSec. We can clear DF bit. So if the packet has a DF bit set, we can clear that before it enters the tunnel so it doesn't get dropped in between. But obviously that's going to incur fragmentation. But that might still be better than dropping the packet totally. So clear IPSec DF bit, clear. Okay, now kind of put everything together with the crypto dynamic map, since we do not know again which the IP the client's going to be coming from, so we can't really specify the exact IP. So instead we're going to do dynamic map. First we're going to set security. Actually, let's take a look what other options we have. Okay. Let's look at match address, and again, since we don't know the address that it's coming from, we're not going to do the match statement at all, and that's kind of the characteristic of the dynamic map. Instead, we're going to do the set statement. We can do set. Let's see, IPSec profile, we need that for sure, because we created one called EZVPN IPSec profile. Then you need to set PFS group 2. Next you set reverse route. That's fine. We'll leave that alone. Security association, and you can do it by idle time, lifetime, and replay. And this is how long it takes before you can do lifetime, how long it takes before the phase 2 start doing a rekeying. You can do either by the amount of data that's been coming through, we're just going to do like 1 gig, or we can do by second, and just do 8 hours. That's the 28800. Now we're going to have to set transform set, and again it's the one that we created earlier, which is ESP AES 256 SHA. And the last command that we're going to put in is reverse route. Although it's not going to be doing much for us, but in case you do things like routing protocols with the next hop device, it might be beneficial to turn on reverse route, so just to let the rest of the network knows how to get to the remote IPs. But we can also pretty much accomplish the same thing with the static route and then redistribute, but here we're just going to do reverse route. We can do crypto map, VPN map. Let's pick like a large number, 1,000. IPSec, ISACAM, and then tie to the dynamic, which is the one we created. And finally, we tie the crypto map to the interface that you want to enable the IPSec on. Okay, let's take a quick look at our config and make sure everything looks right. Got our profile, you got our dynamic map, and you got our EZVPN map. You can see as soon as you tie the crypto map to the interface, there's a log message that ISACAM is now turned on that interface. It's actually quite a bit of configuration on the server side, but you'll see in a second that the configuration on the client side is actually minimal. And that's the whole advantage of using EZVPN, because if you have to deal with a large number of client sites, then your client-side configuration, it will be pretty straightforward. Okay. So now let's go ahead and configure R2. Let me actually copy some of the config out so we have that as our reference. Okay. Now in R2, just to show you the IP configuration, inside 128.1, outside 222.10, and 222.10 can ping 111.10, which is the headend IP on R1. First on R2, we are going to configure ISACAM policy, although you don't really have to, but if you happen to have multiple ISACAM policies in R1, maybe it's a good idea to specifically tell R2 what policy is acceptable to it. So here we already have that copied out. We might as well just copy the rest of these phase 1 parameters. Okay, so those are in. Next, we're going to configure a crypto EZVPN client. And we're just going to call it EZVPN. Let's take a look at the different options. Okay, we do not do access lists. That's usually for dealing with multiple subnets. We only have one headend, so no backup for connect. So you can do ACL, auto, or manual. Here we're going to do auto for now. We'll look at some of the options later on. So connect auto. We're not doing TCP encapsulation. Group. We have to specify which EZVPN group that you want a client to connect to. That would be EZVPN group name that we create with the key of Cisco. Idle time, let's say 1 hour. Mode, we have 3 different modes here, and I'll create a separate video that talks about that, but for now we just gotta do client mode, which is the simplest type of EZVPN mode. Peer, we specify the headend IP, and you can tell that's the default, which is the primary. Username will be site, password Cisco, just to match the user account we created on R1. And last piece of config is XAuth, user ID, mode, and we want to do local and that's to tell the router to use locally store username and password that we created right here. Okay, we can do interactive, we can do HTTP intercept, and we can take a look at that in a second. For now, let's do local. And to enable EZVPN, you have to specify the inside-outside interface. So F01 is our outside, should be IPSec client, EZVPN. You tell which one it is and specify whether it's inside or outside. We're going to give it outside. And then for the inside, we tell it it's inside. Okay, so as soon as you completed that, you see ICAM came up, as well as the EZVPN connection. So it automatically is from based on our configuration earlier, it automatically is bring up the tunnel regardless of the whether or not there's actually traffic between those two subnets. Okay, you can see two interesting notes here. It create a loopback 10,000 for you, and it's also create an NVI 0 because when you run on the mode client, everything gets NATed to an IP that's allocated by the headend device. So if you just show IP interface brief, here you have the IP that was allocated by the headend device, which is 100.32 from the VPN pool that we created. It's also automatically create an NVI 0. Okay, so let's do some ping tests. Here I have a test machine on .32 that's trying to ping 172.16.32.1, which is the switch IP. You can see you can ping successfully. If you do show crypto ISACAM SA, you see status in QM idle. And if you do show crypto IPSec SA, you can see there's NCAPs and DCAPs packets. Okay, we do show crypto IPSec client EZVPN. Okay, although when you look at the IPSec SA output, it looks as if everything is not split tunnel because the destination subnets are all 0. But if you actually look at the output of the show crypto IPSec client EZVPN command output, you can see the split tunnel subnet show up, which is just 172.16.32. Okay, just go through this line by line. You got tunnel name EZVPN with the outside-inside interface specified with the current status as being active. Idle time is 1 hour. With the allocated address 100.32. DNS, again, all of these are configured on the headend side. DNS, domain, PFS, allowed safe password. So everything looks good. And on the switch one, we can do a debug IP ICMP. Let's try out ping again. You can see the IP is, the switch is seeing the ping coming from 100.32, which is everything gets NATed, so it doesn't come across as the 128 subnet. One thing for you to note is we happen to use our switch one also as an internet switch. So you're trying to ping 2221. You can see it's pingable. Let me stop that debug real quick. Okay, let me start again. Okay. When you ping that, you can see how the switch, being an internet switch, seeing the ping packet coming from 22210. Although we have not really configured just to show you an R2 any kind of network address translation, you can see we do look for a keyword NAT. There's nothing show up, but if you do show IP NAT translation, there's actually entries in the table And here you can see a 128.32 going to 2221 gets NATed to 222.10. Although in the client mode we have not specified an explicit NAT statement, it assumes that anything that doesn't enter the IPSec tunnel will get NATed or padded, to be exact, to the outside interface IP, which is 222.10. Okay. So if you keep this particular VPN tunnel up, the remote sites will have access to both headend resources as well as the internet access. And also, according to a Cisco documentation, EZVPN client mode is not really interoperable with the NAT configuration. So if you have the conventional NAT configuration in the router, it might interfere with your EZVPN tunnel. So if you run the client mode, it's best to leave the tunnel up and then just rely on the NAT that's configured or automatically configured for you for the internet access. Otherwise, you might want to look into the other modes, which is the network extension mode. Okay, so you can see the configuration on the client side is pretty much minimal and can be templatized. So crypto right, so you can easily copy and paste that to another router that you have for another site, and the tunnel will just come up with no configuration modification required on the headend side. Okay, so that pretty much wraps up our video on the EZVPN with the pre-shared key and XAuth authentication. Thank you for watching LabMinutes.com. I'll see you guys in the next video.